Thank you for the introduction. So I am indeed thermal management expert at Melexis. So what I want to do today is firstly start with a short introduction on Melexis to give a bit of context for people that might not ring a bell directly. Secondly, I want to introduce some of the most exciting releases of products that we have done in the last months for thermal management products. And thirdly, I want to share a bit of original research on the impact of pressure accuracy and temperature accuracy on the thermal management efficiency and on the vehicle level costs that could be saved. So to start off, so we are a company with over 35 years in the business of IC design for automotive. We design sensors and motor drivers, which is LED drivers, motor drivers for automotive. Our most famous product is the Triaxis, which is a magnetic position sensor used in valves and as a magnetic resolver, for example. We are about 2,000 employees sharing the same passion for innovation, located in United States, Europe, and Asia. Revenue is about 100 million last year, almost peaking at 1 billion in 2023. So our product portfolio is a diverse set of driver solutions, embedded drivers, smart drivers, but also sensors like optical sensors, current sensors, latches and switches, and so on. We are active in many different focus areas, powertrain, battery, which matches perfectly this kind of conference, thermal management, which I will discuss in a second, braking and steering, and also lighting. So these sensors are applicable to these different areas. So for thermal management, the solutions that we have are listed here. To start off, we have pressure and combined with temperature sensors, which are used in the refrigerant lines, so on the high side of the refrigerant and the low side of the refrigerant. Also, they are used in the coolant lines to measure the pressure there. Second, in the fans, pumps, valves, and so on, we have motor drivers, embedded motor drivers running flash software with feedback from the position sensors and latches and switches. For temperature, we have a contactless temperature solution, which is traditionally used for things like cabin monitoring, like measuring the average temperature of a cabin. But we see new applications in coolant monitoring, where we measure contactless the temperature of the coolants. And lastly, current sensors, which are used in high voltage compressors and PTC heaters. So for these current sensors, so let's dive into that first. We have already a longer time conventional hulls and EMC hull solutions there. But of course, easy integration is a big topic, and therefore we have released some couple of years back the coreless integrated primary. And what's special about this product is that the current is going directly through the package, which means that we can calibrate on package level. So we don't, with the other solutions, you have to match the magnetic fields to the currents, which is a compensation step or a characterization step that you have to do on module level. But here we can calibrate, compensate for temperature effects and so on package level. So the current is very close to the sensing IC there. So this is a plug-and-play solution. This sensor is used in PTC heaters, high voltage compressors, but also there are many applications in the car. Then our embedded motor driver solutions. We have LIN motor drivers for below 1 amp solutions, driving the valves, motors, and so on. And for higher amps, we have LIN pre-drivers, which still needs the FET to drive these high currents. An example of this is our Gen 3 LIN BLDC pre-driver, which goes up to 2000 watts and is suitable for 48 volts with 64K flash inside, ideally suited for engine cooling fans, water pumps, and oil fuel pumps. So all that in a small package size, ideal to really miniaturize these valve solutions. And of course, we see this trend in thermal management of really trying to integrate, putting everything on one PCB as much as possible, zonal controllers and so on. And therefore, we have launched recently this serial motor controller, which is fully controllable by I2C and UART, and SPI, and also PWM. So it's ideally suited for small power motor controllers in thermal management. Then for the temperature, we have a unique product where for a longer time, we already had this TO-CAN solution, which is used for things like bus bar monitoring. Basically, it is a contactless far infrared solution that measures the temperature of the surface that it is looking at, meaning everything within 50 degrees angle. And you can put it on a PCB. For example, it is used in monitoring the power FETs of the inverter, where the big advantage is that you have a very fast response time with this solution. Now, we also see some application where it could be used to monitor the coolants. So the advantage there is that integration is much easier. You just have to look at the coolant, provide some window or a surface that is at the same temperature of the coolant to monitor the coolant, and the part itself can be on a PCB. There we are releasing a solution that is even much smaller than the TO-CAN. It is an SMD component, where we are the first to come with such a solution, automotive grade. So it has a 50 degrees field of view, a single pixel solution. So that's it for temperature sensors. Of course, we also have our Trifibian pressure sensor. And here, I'm very passionate about this product because I worked on it for the past 5 years, almost full time. So I want to go a bit into the philosophy of this product. Because at Melexis, we like to understand the value that we offer with this solution. So for that, we dived into the application, where we asked ourselves the question, what does an accurate pressure sensor bring to the system? Like on system level, on vehicle level, what does such a sensor bring? If it is more accurate, what does it bring to cost savings at vehicle level? And for that, we partnered with Satello, a company that does modeling. So we modeled what, in our view, is the architecture that will come in the future. Of course, it's not certain when, but it will be R290 full secondary loop and R1234F direct architecture. And modeling that in the MOLA with a calibrated model, we can see what the system power uses under different conditions. So what we did in this model is we replaced the pressure sensors with the known benchmark that we have. So we benchmarked our Melexis solution with that of the two main industry players in this space, so providing PT sensors. You can immediately see that the Melexis solution has an accuracy that is significantly better. So Melexis provides an accuracy of 0.5% full scale, while the competitors Overlife and 5 Sigma is more like 1.5%. Also on the response time of the Melexis solution is better. Now, taking these specs and putting them in the simulation, what we do is we simulate all the different operational modes of the system, because the EV is, of course, heating, cooling the battery, and so on. And we are looking at the ambient temperature and when these operational modes happen, and then take a weighted sum to arrive at an average energy saved while driving the car. So for the operational modes, for the R1234YF system, these are the most relevant, so the cabin cooling, cabin heating, reheating, and cabin cooling plus battery cooling. And the impact that the sensor has is that if you have a more accurate pressure and temperature information, the superheat can be tuned or controlled much better and a bit closer to the safety limits. Same with subcool and same with the discharge pressure and temperature. From that, we get the power use over the ambient conditions. And zooming a bit in, you can see the difference. So the difference between the Melexis solution and the competitors. For example, we see for the R1234YF architecture that at -20, there is a difference in power use of about 300 watts. And it is because the PTC heater will not be activated with the Melexis solution at that point. So that's where the difference comes from. And then, for example, at 30 watts, there is a difference of 100. At 30 degrees, there is a difference of 100 watts. Of course, it's not always -20 outside. It's not always 30 degrees outside. So we weight this by the average temperature in Europe, arriving at 32 watts for competitor 1 and 59 watts for competitor 2. This is the equivalent of leaving your headlights on while driving all the time. So that's the energy that can be saved with replacing the pressure sensors with better pressure sensors, so tightening the accuracy spec. That is what the results show. And if you translate this to a driving range extension, you arrive that it extends the driving range according to the WLTC drive cycle by 0.65%. Or it also means that with the same driving range, you can install about $78 less battery. So by replacing the pressure sensors, tightening the accuracy spec, you can save at vehicle level $80 while the customer sees the same thing. For the R290, we did again the simulation, arriving at similar results where it arrives at up to 48 watts saved or $66 in less battery installed. Now, what is this pressure sensor that can do this? Well, it's the Trifibian pressure sensors. We have a 0.5% accuracy spec with this over life. And the way we built it is we did something a bit maybe crazy. So a MEMS pressure sensor has been used for a long time, but usually it's used up till 5 bar. What we did is we designed it for up to 70 bar and put it directly in a package where it is hanging in the cavity. Therefore, we don't need a gel on this, and we can handle this harsh refrigerant environment, which is two-phase flow, so gas or liquids. And because the silicon is stable, it reaches about a 2 times better accuracy, 3 times better accuracy. On top of that, like the current sensor, we have the full system in package. Therefore, Melexis, we calibrate this at our site. So arriving at the customer, it's already calibrated on package level. All the stresses that the MEMS see are already present, so therefore we can calibrate it very accurately. And it's basically a plug-and-play solution, meaning everyone can integrate it. It's also a small solution. It's an SOI 16 standard package, meaning you can use this, and we see some customers doing this, integrate this pressure sensor directly in the compressor or directly in the valve. So, which can really miniaturize the system. And if we want to reach that low charge propane system, this is an enabling solution. So we want to contribute to that with this solution as well. So what do I want to say? Well, I want to show that making these design choices reaching the really absolute state-of-the-art in accuracy can really have a big impact on vehicle total costs. So either you have on your TMS a better system performance, so system efficiency, or you have on the vehicle level a $68 or up to $68 cost saved or production cost saved. So let's talk about that further. Meet me at our booth and we can discuss. Thank you. Yeah.